Hi everyone, and welcome to the second of two videos going through some past exam questions on the topic of electronic structure. This first question is asking us about some orbitals. So it's saying the electrons in the second shell of nitrogen are found in an s orbital and three p orbitals. State in words the 3D shape of these orbitals. So the s orbital is a spherical shape. These are just things that you need to remember. And the p orbital, there's various kind of different things you can say here, but the one that they look for most often is a p orbital is a dumbbell shape. It's kind of this sort of figure of eight kind of shape. I'm rubbish at drawing. But it's essentially that kind of shape, and they usually describe it as a dumbbell shape. This question here often catches people out. It's worded kind of strangely. So it says, describe the relative energies of the 2s orbital and each, in bold for some reason, of the three 2p orbitals. Okay. So it's 2 marks. They're asking us to do two things here, right? The relative energies means we're comparing them. Yeah, anytime you see relative, it means we're doing a comparison. So let's compare the energy of the 2s orbital to the 2p orbital. Well, 2s is lower in energy, isn't it? Okay. So that's going to get us 1 mark. The 2s orbital is lower in energy than the 3 times 2p orbitals. But then why have they put each in bold here? Well, we've compared the 2s orbital to the 2p, but then it's saying talk about each of the 2p orbitals, so it's now asking us to compare those to each other. Okay, so the second mark is for saying the 3 2p orbitals have equal energy. That's where we get the second mark. Okay, next bit here is asking us about ytterbium. So it's telling us it's got atomic number 70. It's the first element in the periodic table to have the first 4 shells full. Okay, so it's going to have all the first 4 shells full up. State the number of electrons in the 4th shell of ytterbium. Well, it's telling us that it's going to have its 4th shell full. It's got the first 4 shells full. That's quite difficult to say. So if the 4th shell is full, it's going to have 32 electrons in it. Okay, remember we follow this 2n squared rule. If n is 4, 4 squared is 16, 2n squared, then it's going to be 32. How many orbitals are there in the 3rd shell of ytterbium? Okay, so let's work this out. In the 3rd shell, we're going to have 3s, we're going to have 3p, and we're going to have 3d. Okay, there's no such thing as 3f. Okay, those are the only subshells that you have in the 3rd shell. 3s, well, there's only ever one s orbital. 3p, there are 3 different p orbitals. And in the 3d subshell, there are 5 different orbitals. Okay, so therefore, how many orbitals do we have? 5, 6, 7, 8, 9. 9 orbitals in the 3rd shell. Okay, and that's just how many orbitals are there in the 3rd shell. Which element it is irrelevant. Okay, the 3rd shell has 9 different orbitals in it, and that's where they are. Then we've got a question here which is asking us, show the order in which the next 2 subshells are filled. Okay, we've got 1s, 2s, 2p, 3s, 3p, 4s. Bit of a weird question this, because this is the bit that would catch you out. Okay, the bit that people always forget is that you fill the 4s before you fill the 3d. And they've given you that one, so they're being quite nice to you here, I think. 3d comes next. Okay, this is the bit you've got to remember, that you don't go 3d, you go 4s first. Then we finish the 3rd shell, so now we're just going to carry on from the 4th shell, so we'll go 4p next. Right, this one, state the total number of electrons occupying the p orbitals in one chlorine atom. So to do this, let's just write out the electron configuration of chlorine. Okay. So chlorine on our periodic table is here. So we're going to have 1s2, 2s2, 2p6, 3s2, 3p5. Okay. So chlorine's going to end up as 3p5. Total number of electrons occupying the p orbitals. So how many have we got in p orbitals? We've got 6 there, and we've got 5 there. So it's going to be 11. Okay. How many electrons are there in one ion of calcium 2+? This is nice and easy. It's not, you could answer this at GCSE. So if we find calcium, Calcium has an atomic number of 20, so it should have 20 electrons, but a calcium 2+ ion has lost 2 electrons, hasn't it? So it's going to have 18 electrons.